Hello students, welcome back. I hope you have watched my last video. In our last video lecture, we have completed exercise 7.11. That is for chapter number 7, integrals. If you like my video, then please subscribe this channel. Today we will start with exercise 7. Okay, so today I am not going to solve any sum completely. I am going to give you hint. So I have selected few questions from exercise 7 in which I will give you some hint and then you have to solve it completely by yourself. Okay, so we are not going here in sequence. Okay, the other sum which are remaining that I will solve it completely in our next video. Okay, so let's start first with question number 1. Okay, see, question number 1 is integration of 1 upon x minus x cube. Okay, so what can we do here? It's 1 upon x minus x cube. I can take x common. So it will be 1 upon x into 1 minus x square. Now what is 1 minus x square? A square minus b square. A minus b, a plus b. So this will be equal to 1 upon x. 1 minus x, 1 plus x. Okay, now just remember which method is this? This is the method of integration by partial fraction, right? So what we will write it down? 1 upon x, 1 minus x, 1 plus x. This will be equal to a by x, b upon 1 minus x, c upon 1 plus x, right? So it will be 1 upon a into 1 minus x into 1 plus x, b into x, c into 1 plus x, c into x into 1 minus x. Right? Put down different values of x and find out the values of a, b, and c. And then finally integrate it. Clear? So here will be whatever the value of a into log x plus b into log 1 minus x, and as it is minus, it will be minus plus c into log 1 plus x. Clear? So you solve this by integration by partial fraction. Clear? Now let's move to the next one, that is question number 6. Question 6 is integration of 5x upon x plus 1 x square plus 9 dx. Now see, here also it is in the form of p of x upon q of x, polynomial, right? See here, x plus 1, x square plus 9, right? So see here, this will be a upon x plus 1, and this is second degree polynomial, right? So that's the binomial. Okay, now see how we can do it. I will take it as phi x upon x plus 1 x square plus 9. Okay, this will be equal. Now see, wherever there is a second degree binomial, okay, so what we were doing, bx plus c means a upon x plus 1 plus bx plus c upon x square plus 9, right? In this case, the degree of polynomial denominator is higher than the numerator, so we can directly solve it in this way. Or else a upon x plus 1 plus bx upon x square plus 9 plus c upon x square plus 9. Separate it in the starting only, right? So phi x will be equal to a into x square plus 9 plus bx into x plus 1 plus c into x plus 1. Take different values of x and find out value of a, b, and c. And if it is required, you can also use the other method, that is comparison of coefficient. Right? Compare the coefficient of x on here, it's 5, and x on here. X square on here, it is not there, so 0, x square on here. Clear? And by that way, find out the value of a, b, and c, and then integrate it. This will be equal to log, and this will be equal to tan inverse. Okay? So solve question number 6 by again integration by partial fraction. Clear? So let's move to the next one. Question number 7. तो क्या है question number 7? It's integration of, okay, we had solved a similar type of sum. It was like this, question number 11. Right? What we had did sine a minus b, multiplied divided by sine a minus b, and then adjusted the numerator. So here directly we can adjust the numerator here only. What I can do, sine x minus a plus a upon sine x minus a. So this will be sine alpha plus beta sc plus cs upon its s. Clear? Here the angle will be x minus a, so sine x minus a is x, sine x minus a. You make a cancel. Cos a, that will be the constant. And in this case, cos x minus a upon sine x minus a, that will be cot. Okay? Into sine a. Sine a is constant, right? So now integrate it directly. Right? First is cos a, so it will be x cos a. Second is sine a constant into cot x minus a. So integration of cot x minus a will be log of sine x minus a. Clear? So use this method and solve the integration. Okay, solve it. Question number 7. Now let's move to the next one, that is question number 9. Now see, what is question number 9? Integration of cos x upon square root of 4 minus sine square x. Okay, so just recall which method we can use it. Okay, see here you can see in the denominator the root of 4 minus sine square x. So whenever there is denominator, we were having formulas, integration of 1 upon x square minus a square, root of x square minus a square, integration of 1 upon root of x a square minus x square, or x square plus a square, right? Sometimes we are making perfect square, so we'll use that method. But here we are already having square, 2 square minus sine square. But in the numerator, I am having cos x. Now just imagine, if I assume sine x as t, what will happen? Its derivative of sine x is cos x. I will get the numerator. See, you have to here assume sine x equal to t. That will be cos x dx equal to dt. So this will be cos x dx square root of 4, so 2 square minus sine x t square. So now it's the formula, integration of 1 upon root of a square minus x square. Okay, so what is this formula? It will be, what is this formula? Sine inverse x by a plus c. So here will be sine inverse t by 2 plus c, and then replace the value of t. Clear? So by this way you are going to solve question number 9. Clear? So let's move to the next one. Question number 11. 1 upon Okay, it's 1 upon cos x minus a into cos x plus b. Sorry, let me check the question. It's x plus a, right? So this type of sum we had already done in the previous exercise. Okay, that I was talking about in this sum. What we had done, we had adjusted, multiplied and divided by sine a minus b. Right? So see how I can write it down. I can write it down sine a minus b as sine x plus a minus x plus b. So see, sine x gets cancelled. So it will be a minus b. So what I have to do, multiply by sine a minus a, sorry, a minus b divide by sine a minus b. So this denominator constant, I will take it out. Integration of, instead of sine a minus b, I will write it down plus, sorry, minus upon dx. Okay. So now see what will be happening. It will be sine alpha minus beta s c minus c s upon cos into cos. So see here, first here it will be sine x minus a sorry, s cos x plus b. So cos x plus b, cos x plus b will cancel. Sin by cos 10. In second, this cos will be cancelled, and second also will be 10. So in both the cases, it will be integration of 10. In one, it will be 10 x plus a, and other there will be 10 x minus b. So what is integration of 10x? Integration of 10x is log of sec x, right? And in minus, this will be into division. So it will be log of sec upon sec. And that sec you can replace it by cos, 1 upon cos, right? So try to solve it. Okay, question number 11 in this way. Remember, 1 upon sine minus a. I have divided by sine minus a, multiply by sine a minus b. And divide by sine a minus b. Okay, so this was the method for question number 11. Okay, now let's move to the next one. The next is question number 12. Question number 12, it's here only. X cube upon square root of 1 minus x raised to 8 dx. So again in denominator it is square root. Now just think, here it is the 8th power, right? X raised to 8. And in numerator it is x raised to 3. Right? So if I assume x raised to 8, it will be derivative of it will be 8x raised to 7. But if I assume x raised to 4, right? So what will happen? I will assume let x raised to 4 equal to t. So now when I will differentiate it, this will be 4x cube dx, and here it will be dd. I am having x cube dx, right? I'm having x cube dx. So x cube dx will be equal to dt by 4. Clear? So now what will be our integral? Instead of x cube dx, dt by 4, and this 1 minus, we had assumed x raised to 4 as t. So x raised to 8 will be equal to t square. Right? Once again, integration of 1 upon root of a square minus x square. It will be sine inverse x by a. So sine inverse t by 1. Okay, and then replace the value of t as x raised to 4. Clear? So this was about question number 12. Clear? Now next, let's move to the next sum. Next, question number 13. Integration of e raised to x upon 1 plus e raised to x 2 plus e raised to x dx. Okay, so see how we can solve this. If here it was x, 1 plus x, 2 plus x, it's simple. Integration by partial fraction. But in numerator it is also e raised to x. So let's assume e raised to x. So what you have to do? Let e raised to x equal to t. So what is the differentiation? E raised to x dx equal to dt, right? So now what, this sum will be replaced by this way. E raised to x dx, that will be equal to dt. Clear? And 1 plus e raised to x, we had assumed e raised to x as t. So 1 plus t, 2 plus t. Clear? So now it's simple. Integration by partial fraction. Like 1 upon 1 plus t, 2 plus t. A upon 1 plus t plus b upon 2 plus t. Clear? Okay, so now just find out the value of a and b. And put it will be a log 1 plus t plus b log 2 plus t when you will integrate it. And finally replace the value of t as e raised to x, right? So this was about question number 13. Solve it by this way. Assume e raised to x at t and then integration by partial fraction. Okay, now let's move to the next one. Next, question number 14. 1 upon x square plus 1, x square plus 4 dx. Okay, so what we can do here? See here, if it was x plus 1, x plus 4, you can easily solve it by integration by partial fraction. But here it is x square. So to just find out the value of a and b by integration by partial fraction, I will consider x square as t. Means I will take it as like this. 1 upon, consider x square equal to t. So this will be 1 upon t plus 1, t plus 4, right? So this will be equal to a upon t plus 1 plus b upon t plus 2. Okay, so now find out the value of a and b. See, here we are not assuming x square as t. If we are assuming x square, it will be 2x dx equal to dt. We are not going to replace x by t. Clear? We had done this only to find out the value of a and b, so that we can split the numerator, right? So once you get the value of a and b, again write down this will be a upon x square plus 1 plus b upon x square plus 4. And if we will integrate it, then the formula will be 1 upon x square plus 1, tan inverse x by a. Okay, so don't integrate in the form of t. We are only putting this x square as t to find out the value of a and b, and then replace here only. Before integrating, replace the value of t as x square. Clear? So again, this is integration by partial fraction. That was question number 14. So you have to solve it by this method. Now let's move to the next one. The next is 21. Question number 21 is 2 plus sine 2x upon 1 plus cos 2x. Sorry, it's e raised to x. Okay, it's 2 plus sine 2x and in denominator 1 plus cos 2x into e raised to x. Now see, there was a method in which where there was e raised to x, we were using e raised to x fx plus f dash x, right? So we'll try to rearrange it in that way. Okay, so see 1 plus cos x. Okay, if I convert it into a single trigonometric value, what has happened? I can separate it 2 upon this plus sine. So 2 upon 1 plus cos 2x plus sine 2x upon 1 plus cos 2x. But let's convert this 1 plus cos 2x. I can write it down this as 1 plus cos 2x. That is 2 cos square x. Okay, in other way, cos 2x is 2 cos square x minus 1. So plus 1 minus 1, it is 2 cos square x. And here 2 plus, instead of sine 2x, I can write it down 2 sine x cos x e raised to x dx. Now when I will separate it, 2 will get cancelled, 1 plus 1 upon cos square x, sec square x, okay? And 2 gets cancelled, cos cos, sine by cos. So now see here, fx after x, right? One is the function and another is its derivative. So e raised to x fx plus f dash x. Tan x is the function and x square x is its derivative. So it will be e raised to x tan x plus 3. So solve it further, okay? So this was about question number 21. Now let's move to the next one. The next one is question 22. Okay, x square plus x plus 1 upon x plus 1 whole square into x plus 2. So now I will put it as square. When I will square it, it will be x square plus 2x plus 1 into x plus 1. So the highest degree of x will be equal to 3. X cube it will be. Right? So in denominator, the polynomial is of higher degree compared to numerator. Right? So now we can directly solve it. Again, we will use here integration by partial fraction. Clear? See now how we can do it. We can solve it here. X square plus x plus 1. This is the method of repeated factors. See, x plus 1, it is repeated twice, it's square. Right? So what I will do, a upon x plus 1 plus b upon x plus 1 whole square plus c upon x plus 2. Clear? So now just solve it x square plus x plus 1 a into x plus 1 x plus 2. When you're solving it, here you are having x plus 1. So just eliminate here 1 x plus 1 plus b. Here having x plus 1 whole square. So eliminate that plus c. Okay. So once you can take the value of x as minus 1, so this and this will be equal to 0, you will get the value of b. Once you take the x of value as minus 2, so this and this will be equal to 0, you will get the value of c. And third, take any random value of x. Let's take it as 0, right? So when you put it here, you are already having the value of a and b. Clear? Put that value of a and b, you will get the value of c. Yeah. So again, after that, integration of this. Okay, this will be log x plus 1, this will be When it goes to numerator, x plus 1 raised to minus 2. So minus 2 plus 1 upon minus 2 plus 1. And this will be log x plus 2. C log x plus 2. Okay? So you have to solve the question number 22nd by this way. Okay? So that's it for today. Today you have to solve question number 1, 6, 7, 9, 11, 12, 13, 14, 21, and 22. These sums, I have already given you hint for all these questions. Right? So you have to try it by yourself. If you have any doubt, then you can either message me or mention in the comment section. Okay? Thank you.